In this question, we're asked to determine the relative boiling points of several different compounds to determine which has the higher and which has the lower boiling point. In this case, if you look at the name of the question, it's the relative strength of dispersion forces. So all of these molecules are nonpolar. However, if you were faced with a similar question like this on a test, you would want to check to see what the strongest intermolecular force is. So here we have CS2, which is an analog of CO2, because oxygen and sulfur are both in group Ca, so 6A. So this is nonpolar because both domains are the same for carbon. And molecules that only contain carbon and hydrogen are also nonpolar. Now, one way you can do this is by the number of electrons, and you can actually count the number of electrons. The other way is, the way I usually do it, is by molar mass. Generally, something with a higher molar mass has more electrons. So this CS2 has a molar mass of 76 grams per mole, and ethene has a molar mass of 28 grams per mole. Since CS2 has more electrons, therefore it's more polarizable, therefore it has stronger dispersion forces, therefore it has a higher boiling point. So quickly to review, we're looking for two nonpolar molecules, so they only have dispersion forces. The one with more electrons, or the higher molar mass, tends to have much stronger dispersion forces, so therefore it has a higher boiling point, so therefore we have CS2 between these two molecules. In this case, you probably don't even need to bother with the molar masses. Hydrogen is a very small molecule, Cl2 much larger molecule, so therefore Cl2 is going to have much stronger dispersion forces and therefore a higher boiling point. Note that diatomic molecules only have dispersion forces. You don't even need to bother with the Lewis structure. Finally, we have GeCl2 and GeCl4 and GeI4. In this case, iodine is much larger than chlorine, much higher molar mass, so therefore this one is going to have a higher boiling point. So essentially we're comparing, because all the molecules are nonpolar, the number of electrons, which can be compared by using the molar mass. Note that this rule doesn't work in all cases, but it is a good general rule of thumb, and it will allow you to answer this question.